Hi children, good morning. Welcome back to our session. What is the lesson? It's going on for us. Electric current and its effects. Is it? So in the last class we have learned about the electric magnet, electromagnet. Is it? Yes. So today's our topic is about the electric bell. Have you seen the electric bell, children? Where it will be? In our schools only, is it? So instead of beating that rod, if you are given the electric current, that itself it is going to ring it, sound it is going to come for us. Have you observed that? Yes. So, and also in the film theatres, interval time comes means they will give one bell for us. Have you observed that? Not observed? No problem. Now I can show how the electric bulb is going to work. Okay? Now see, what do you mean by electric bell? An electric bell is a mechanical or electronic bell. It is a mechanical or a electronic bell that functions by means of an electromagnet. How it is going to work? By the electromagnet. When an electric current flows through the coils, when the electric current is going to flow through the coils, the electromagnet creates a magnetic field. What it is going to create? It is going to create the magnetic field which pulls the armature towards it, causing the hammer to strike the bell. How it is going to work, children? When an electric current flows through the coil, when the electric current is going to flow through the coil, then the electromagnet inside, it will be the electromagnet that itself creates the magnetic field which pulls the armature. So armature means it is going to beat it towards it, causing the hammer to strike the bell. So this is about the electric bell. So how it is going to work, I'll show through a small video. Watch the video and once again come back, children. Okay?
Good morning, children. Today we shall learn how an electric bell works. Most of us have seen it. You know, this bell also works on electromagnet. Confused? Let us first refresh our memories. We already know when the electric current passes through a wire, it behaves like a magnet. This is the magnetic effect of electric current. Also, a current carrying coil of an insulated wire wrapped around a piece of iron is called an electromagnet. The power of this electromagnet can be increased by increasing the number of turns of the coil. It can also be increased by increasing the flow of current through the coil. Let us also not forget, electromagnet can also be turned off by stopping the electric flow of current which made it a magnet. Now that we are clear about the electromagnet, let us now understand how an electromagnet is used in the functioning of an electric bell. Let us see the simplified circuit of an electric bell with the switch in off position. It consists of a coil of wire wound on an iron piece bent to form U shape like a horseshoe magnet. A spring-loaded arm made of an iron strip is kept close to the electromagnet. This arm has a hammer attached to it at one end. Let us call it a clapper. A small gong or bell is also placed near the hammer. See, there is a contact screw near the clapper. Now, let us switch on the circuit and the fun begins. Right now, the clapper is in the contact with the screw. So, the circuit is complete and the current flows through the coil. Due to the current flow, the coil becomes an electromagnet. The electromagnet then pulls the clapper towards itself. In this process, the hammer at the end of the clapper strikes the gong of the bell to produce a sound. Let us see what else happened when the electromagnet pulled the clapper and we heard the hammer striking the gong. Look closely. Right now, the clapper is not in contact with the screw. The circuit is broken now. So what will happen next? The current through the coil will stop flowing. Will the coil remain an electromagnet? No, it wouldn't. The coil is no longer an electromagnet. As we know, it's the flow of the current that gives the coil its magnetic power. So, it no longer attracts the clapper. The clapper springs away from the bell back to its original position and touches the contact screw again. This completes the circuit. The current flows in the coil and the hammer strikes the gong again. This process is repeated again and again very quickly. Thus, the hammer strikes the gong every time the circuit is completed. This is how the bell rings. Interesting application of an electromagnet, isn't it? So, in a nutshell, by turning an electromagnet on and off, we made a useful thing, an electric bell. Using this electromagnet, we created the movement of the clapper to ring the bell. With the current flow, the electromagnet attracted the clapper, ringing the bell. But it also broke the circuit and stopped the current flow. Due to this, the electromagnet lost its magnetic power and the clapper went back to its original position, making the contact with the screw again. This made the circuit complete and again the clapper struck the gong. Great, isn't it? So the next time if you get any chance, do analyze the circuit of an electric bell. See you next time. Till then, have fun. Bye bye, kid.
Have you watched the video? Now you got the idea how the electric bell is going to work? Yeah, really a good understanding video, is it? Yes. So by this, that we completed this session. Not only the session, children, we have completed the chapter of electric current and its effects. So let me go for the new topic in the next class. So for this class, it is the ending session and also the ending of the chapter. Okay. Thank you, children.